this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 6-7 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to translate between recursive and explicit definitions. So, real quick, let's get some definitions in here. So for something to recur means for it to happen over and over and over again. So we learned in our last video how to make a recursive formula. Now recursive formulas are usually used to generate a sequence. Now an explicit formula, to do something explicitly, means that you are specifically solving for a single value somewhere down the line. Alright, so we can have two separate formulas for the same sequence, one that's recursive and one that's explicit. And it's very important that we can jump between the two. So with an explicit formula, we don't write a piecewise function, we just write the equation in Algebra 2. Okay, so remember recursive I thought was really weird because in Algebra 1 we just wrote two equations. In Algebra 2 they put it as a piecewise function. But now that we're in Algebra 2 with explicit formulas, it's the same as Algebra 1. Alright, so our explicit formula says to find a term, you take the first term and multiply it times the common ratio to the n minus first power. So all that we have to do is we have to look at our recursive formula and identify our a sub 1 and our r. So in this case, our a sub 1 is the value of the function when n equals 1. So our a1 is 5. Now our common ratio in a recursive formula is the number down here that's multiplied times a sub n minus 1. So my common ratio here is 1/2. So now I can use my explicit formula to just write it out. So I have a sub n is equal to a sub 1, which is 5, times the common ratio, which is 1/2, to the n minus 1. So everything that's written in black in this formula stays the same every time. You just change your a sub 1 and your common ratio. So that's easy enough. So now we're going to go backwards and we're going to write the recursive definition. So remember, for the recursive definition, you're going to write a piecewise function with some expression when n equals 1 and another expression when n is greater than 1. Now when n equals 1, that's our first term, or our initial value. So when I look at this explicit definition, that would be my 3. Now the second part, remember you take your common ratio, which in this case is the number with the exponent, so 2, and you multiply that times a sub n minus 1. Alright, so now let's do the try it. Alright, it's going to be the same process. So first I need to identify from this recursive formula, I need to identify my a sub 1, which is 12 because that's where n equals 1. And I need to identify my common ratio, which is the number times a sub n minus 1. So my common ratio is 1/3. So to write my explicit formula, I know I have a sub n, and I know I have something raised to the n minus 1 power. And I just fill in the values. So a sub 1 is 12, and I'm multiplying that times the common ratio to that exponent. Alright, so now to go from explicit back to recursive. So I have a sub n equals, recursive formulas, we're doing like this with our piecewise function. We're looking at when n is equal to 1, and then we're looking at some number times a sub n minus 1, and that's when n is greater than 1, and we just fill in our two values. So a sub 1 here is 12, and the common ratio, ooh, not 12, looking at the previous problem, shame on me. So our a sub 1 is right here, it's that 6 And then our common ratio in this one is 1.2. So there we have it, guys. That's translating between recursive and explicit definitions. Until next time.